All right. So again, Rodrick, Saylor, GRW Engineers. I want to begin by saying thanks to Jeff and Mick for inviting us out, or inviting me out, and all the speakers. I think it adds a lot of context and purpose to what we do. So much so that I've abandoned most of what I was going to do and have now got some other stuff I'm going to fit into here. So I'm going to jump around just a little bit as I go through here. So bear with me. So starting off, I just want to kind of cover what, let me minimize this real quick, sorry. All right. The beginning of our design process, really there's two services that are going to come out to the field before us. We're going to send out a surveyor, survey if it's a rehab of the existing track, or if we're doing a whole new track in a whole new field, we'll get the ground surveyed and do geotechnical investigation as well to determine what the soil is like underneath the track and if there is rock. And I'm going to lean on a couple of tracks a lot throughout the presentation. One is Windstar, and I'll probably have a little bit of Belmont in here as well. This is the existing track as it was a year or so ago at Windstar. This was, as I mentioned the other day, this is my first track that I ever got to do when they originally contacted GRW to do this. We modeled it somewhat at the time after Keeneland's training track. So if you're familiar with Keeneland's training track, you got a large radius on one end, a little bit smaller on the other. I think it's 180 or 280, maybe 280 on the small end. When they came back to us after years of, kind of running on this track as it was, they decided they wanted both ends of this track to be equal. So we developed a plan that did that. And I'm going to show you a couple photos and some 3D modeling of what we did with this. I'm going to jump out of here. I will stick with this just for a moment until I get a chance to zoom in. So the geometry of the track, kind of the first thing I guess we do, we start establishing what the radius is, or radii that they want on the track, or what we want to shoot for. And we work in a spiral curve into that design that kind of softens the turn, softens what I've described as a corner. If you've got a traditional simple curve going from the tangent of the straightaway into that turn, there's actually a little bit of a corner. You wouldn't think of it as a corner, but it does have a little bit of a sharp edge to it compared to a spiral curve, which is going to ease the horses into that turn a little bit easier. And here's my drawings. So this I can zoom into. This is the purpose of getting into this. All right. So on here, the spiral was 200 feet for this track. It'll vary a little bit depending on the size of track. But what that does is it actually brings the beginning of that turn back into the straight just a little bit, and it eases you in until you get into the full radius heading around the turn. In that period, I'll get to in a moment what the cross slopes of the track are and what I call super elevation, or the banking in the turn. The cross slope I believe on this track was 2% in the straight, and then when we got into the full super in the banking of the turn, I think we're at 4 to 4.5. Well, we started at 4.5. I believe we dropped it down to 4 at Windstar's request, kind of midway through this. So I think some of what I'm going to show you is an older set of plans that holds onto that 4.5. To get from the 2% to the 4, we're transitioning throughout the entire spiral. So as we're moving from the beginning of the ST, which is a spiral to tangent, getting into the CS, the curve to spiral, we're moving from that 2% to 4, and we stay in 4% all the way around the turn until we come to the other end, and it mirrors itself on the way back out. There we go. Cross slopes on the tracks vary a little bit from owner to owner or facility to facility that we worked for. We will develop a typical section. I believe this was Belmont's training track. Glenn had contacted us. He wanted to move his outside rail further out and give himself more width on his dirt, or on the training track. This was maybe Indiana Grand, I believe. Similar situation with he's got 2 and 4 1/4, I believe, in his, and I'll zoom in on this. It's 2.5 and 4 1/4 is what is what Roy wanted at Indiana Grand. So I want to get into just a little bit here on these on the elevations, the change of the cross slopes. I go to talk to a lot of folks, and anytime I hear anybody describe their cross slope in degrees, I always want to tell them that I ask them if they're racing penguins, because 2 degrees is really cold. Leave degrees to the weatherman. Anytime you're talking about cross slope of a track, or you're talking about earthwork, you're talking about percent, not degrees. And so to kind of describe that a little bit more, I put a table together. 2% versus 2 degrees over 50 feet is 1 foot at 2%, or 1.75 over 50 feet for 2 degrees. And a little bit of a table down here. It all blends together. It's kind of small, but there's 2% is actually equal to 1.15 degrees, or if you're at a 5%, you're more equal to 2.86 degrees. So they're not compatible. If you're talking about earthwork or your track, make sure you're kind of referring to percent and not degrees. The common terms you'll hear, a 1/4 inch per foot is a 2%. That's very, very flat. If you're out at I would consider it very flat. If you're in a parking lot and you see ADA parking spaces or a cross slope on a sidewalk, that's 2% generally. That's the max that can be. An eighth of an inch per foot would be 1%. So when we've come out and done rehab of tracks, where's my pointer? We'll withhold the name to protect the innocent. I don't remember which track these are. So, or salute them because they brought us out to kind of fix some obvious issues that they were having with their tracks. So when we conducted a survey on this track, you can see in the red is the existing track that we surveyed, and blue is our final design that we produce a model of that I'll show you in just a moment when I jump back into AutoCAD. You can see over time they have they've worn out their crown. It doesn't exist anymore. And in this particular case, they wanted to get rid of the crown on the inside of this track. Still kind of puzzled now which one I put on here. I've got a couple more examples of that. Here's another example. This may actually be Belmont's training track that I showed you just a moment ago. You can see where maybe the crown existed in this location at the time. Maybe it was right here, but it does this doesn't do exactly what it was supposed to do. So we reestablished the cross slope of the track. This is being the turn at 4%, and then that crown just kind of banks away or falls off the other direction at 2%. And mostly that's to kind of prevent the amount of water. And I got stations up there. It's about, 65 feet or so to the crown. And that just kind of helps prevent the amount of water that would slope and drain, wash across the track when you put the crown in, when you've got a really wide dirt course. Here is wind stars. I'll go back to this one. Because we widened the turn on the west side, I do believe, you can actually see in the existing track was here. When we widened it, made that turn longer, increased the radius of it, it brought it back out over the embankment. So when we completed the design, we had to rebuild the entire embankment. So this is all fill material underneath here. And then this is I don't know what part of the section of the turn this was taken at, but we're probably in that transition zone getting into the full super. We're not quite to the full super at this particular section. So I think, let me do this now. No, here. WinStar. So this is topography lines. This is inside of AutoCAD. This is where all the magic happens for us, the fun part. These are all 1 foot contour lines that represent just change in elevation. The kind of cross section I showed you just a second ago was probably right through this turn. I can probably improve this a little bit and give you some context. So turn on the map that's behind here. You can see where the old track was. We managed to maintain most of the original kind of footprint of the track, except for when we got to this turn and increased that radius, we pulled away from that and ended up having to get into this hillside. So this is going to get into a little bit of the purpose of our geotechnical information and borings during the design process. You can see that we have kind of a turnaround bulb here, and then the chute kind of came out here, made another turnaround area out here. Those, let's see here. So that bulb that you saw is this area right here. So it's, and then the chute kind of coming back here in the back is the kind of the main part of the track over here. And then the turn was kind of coming around this direction. So this kind of highlights the need for that geotechnical information and then the precision of the design process. So when we put our surfaces in here, this is going to be hard to control. But this is, if I can get it rotated. I think Dennis asked me last night how I go from full super or regular super into full super, how often I take sections around that track. I don't actually do that. The way we design our program, you can see we're coming down the straight here and then it banks and comes around here. So at any point in time, I can pull off an elevation as we're going from 2 to 4% or whatever it is in that turn. You can see here that there is a gallop that's kind of attached to it that kind of takes off and goes uphill back behind the track. And you can see how it gets a little bit steeper here in the turn. And that's, so at any point in time, I can pull those elevations. I go back, I'll close this guy. Go back into here, I can probably hover at any juncture. That'll be on the track here. It tells me what my surface is here at 873.48. So when we finish our design, contractors these days, especially with Belmont, or excuse me, Windstar, they took our three-dimensional model, what I just had on the screen there, and plugged that into their dozers and their equipment, and we're able to mimic exactly what we intended that surface to be, from its cross slope and its location, including surveying in the spiral get the rail position the way it's needed to be as well. So at any point in time on here, I can just kind of hover and it'll give me what that is. So we can cut sections at any point and give the cross slope of the track in any given location. And this is how I kind of think back to where when Harvey, my boss, mentor, was doing these tracks, mostly on pen and paper or pencil and paper. He still, to this day, prefer to have plan sheets in front of him. I've kind of moved to technology and using technology this way to get the cross slopes of the track and get everything the way it should be. So I guess this one will be Belmont. Same situation. You can see these are all the contours. This is work in progress, not quite done. Turn on the aerial map just to show you where we are. Confirm here. So Belmont's train track over here. So we're working on the main here. If I take and do this thing with this guy, again, it's gonna be a little difficult to control. But you can start to see the tracks and everything that we're working on with them to get their new kind of layout for what's coming for Belmont. And again, when we're done with this will be a 3D model. This information we can take and give a data file to a contractor, and they can take and build exactly as we have it here using GPS units on their equipment. So this program here it's Civil 3 or AutoCAD. This is where we do the meat of our design. We do acknowledge, or at least I acknowledge that, where is looping? Most people can't really look at this plan sheet and kind of start picking that information off. This is kind of a little bit of in the weeds, and some of your owners may not really understand what they're looking at here. So kind of as an additional kind of exhibit we do, I have another program that has helped kind of visualize that. It's really good for conceptual design, and it's even better, I think, for taking what I design out of Civil 3D with the precise measurements and taking that into this program so it can be kind of visualized and kind of shown to folks that aren't used to looking at those construction documents, understand what it exactly is that they're getting. This was, like I mentioned, I think yesterday, our firm, we also have geospatial capabilities. So we did an aerial survey and flew Belmont and did a LiDAR survey and aerial photography. let me make sure I am in the master. So this program will provide, if I can come down here and look in it closer, it'll provide some grades just kind of out of the box. That's what the conceptual part of this program is really well. But when I take and I add in the aerial photography that we did and the LiDAR, you can see that it better defines the bridge up to including, if I go down here to the grandstand, if you've been to Belmont, you know you have this kind of trough area, drainage swell next to the grandstand. So our aerial photography picks this up as well. So this helps us kind of visualize this for some owners that may need a little bit, you know, the plan sheets are a little difficult to look at. I'll highlight this with another track that we're working on at the moment. Give this model just a moment to open. So this is an equine center near Lexington. They wanted to increase this track. It's kind of small. The radius, again, it's pretty small on one end. I think they're looking to maybe get this to 5 furlongs. We have been working, let's see, I think this is the one I want, update it. So on this model, you can come in here, you can see their existing track and their embankment, and then you can see where I've loaded in the Civil 3D, the data for what will eventually start being their extended part of their track and where it ends up. If I switch this again, then this becomes something that the owner can look at this. He's not in construction. He doesn't do any, you know, he's not used to looking at plan sheets. This kind of helps him see exactly what we're doing, where we're putting it. And you can see that the green slopes here are kind of cut and fill slopes. If you zoom in, you can kind of tell that they're fill slopes here. But you can see that we were able to match, and this helps him understand that the earthwork, we did what we could to limit the amount of earthwork needed to build this track, because we stayed almost at grade along this straight and pretty good on this side. But obviously when we got out here in this turn, we're pretty elevated out here, just because I maybe can drop this down a little bit and cut some of this earthwork down, but he'll have to build another embankment very similar to what he's got right here. I think now I got a couple more slides to go back to my presentation now. So we talked about cross slopes, and we talked about the spiral, we talked about the cross slopes and percent. Then these are, so to describe this better, maybe I jumped ahead. These are like, if you take a piece of pie or the track and cut it up like a piece of pie, these are sections at different stations. This was its station 4200 is where this one was taken. So these are sections. Now the next slide here, these are profiles of the existing running line. So this is, and it's gonna be really, really hard to see. So there's a dash line that's kind of ending here, and this dash line meanders. It's kind of moving up and down as you go down your running line. You can see a little bit here, that dash line gets up above the new track surfaces. These two lines would be the new track surface. I think this was Belmont's training track. They had a kind of a peak at one point on the back stretch, and we were trying to take that out. So this is just another way of looking at the design process to understand what your running, your running slope is along the running line. And this will tell you a few things as well. It'll show you maybe where your cushion is thinner, and because maybe the limestone base might be a little higher than you expected in there, or you can see that maybe you've got a whole lot of cushion because the limestone base dips down on you whenever we do the geotechnical boring information investigation to get the information to plug into into the program. I think I have now sped through my entire presentation. Just want to engineer things. I'm not a public speaker, so went through that very fast. Questions? Jim's actually not on here. No questions then? Oh, good. Okay. All right. Thank you.